Hello and welcome to the second of the recorded digital sessions I will be uploading over the next couple of weeks. I hope you were all able to follow along with the previous session on 2D skills within Rhino, and this session is going to be looking at modelling and 3D modelling within Rhino, so we're kind of taking the next step from our 2D drawings we put together in the previous session. As with last week's videos, I'll be breaking this down into 3 or 4 chapters which will be around 10 to 20 minutes long a piece. And this first one will be looking at basic 3D modelling skills within Rhino. We're going to be using the same floor plan that we were working with last week and kind of adapting this and modelling this up in 3 dimensions. Just to kind of go back and show you the reference again, this was sort of based on the Robin Hood Gardens project, which is a housing estate in East London, which is now being partially knocked down. We're going to be working with one flat again, and we're going to start to sort of extrude that up to multiple levels. So if I just open up this image here, one flat is kind of one floor of the flat would be this block here. We're also going to be looking at the level above and the level below, much like this kind of axo drawing here that you can see there. So that's the kind of basis of our modelling, and we're going to be going through a series of skills and techniques to do with that as we go along as well. This first session will be more basic 3D modelling skills, and we'll kind of get more complex as the chapters go on. So to start, we're just going to kind of do a quick overview of where we were last session. So last session we looked at 2D drawing and creating a plan in 2D. Now we focused on one particular level last week, so I've now drawn up the levels above and below this. So this is our kind of level 1 plan, and this is maybe ground floor or level 0, and then this is level 2, the level above. So we've got kind of 3 floors to play around with, which we're then going to look to connect up in 3 dimensions. Now with my layers in 3D, I'm actually not going to use any of my 2D line work layers. I'm going to set up a new series of layers called 3D. And then within these, I'm actually going to layer the elements now by their type, so walls, windows, floors, doors, etc. And the reason for doing this and not doing it in line weights as I did in 2D is because any drawings we'll be getting out from our 3D model we'll be putting back into our 2D line work layers. We'll never be kind of taking our 3D layers and making a drawing straight from those. So I quite like to keep them separated just for sort of ease of use going forward. So I'm going to quickly now pause the video and make all my 3D layers that I'm going to be using over the next couple of sessions. So these are the basic layers I'm going to be starting with. You see within walls I've already kind of broken it into 2 sub-layers, which are my internal and external walls, and as we go along we'll probably be making more layers for each element we're modelling. The kind of key is with the layers in 3D modelling is that you sort of want to layer stuff up by categories, and that way it's sort of easy to select all the windows, easy to select all the walls, vice versa. So just try and think about that while you're modelling elements up, kind of which category it sits in, and make sure it's on the relevant layer. Now we're going to start by setting up our drawing file to work in 3D. So we've got our 3 different plans here, and I've also set up a series of levels, and this is going to help us when extruding out our walls and setting floor heights so we know exactly which heights we're working to. Now obviously everything at the moment is flat and in 2D, and we want to start to transition up into 3 dimensions. So to do that I'm just going to double click and go back to my 4 windows here, and we're just going to work in perspective for the next couple of steps. And we're going to start by rotating our levels so they are not horizontal anymore, they're now going to be vertical, so we can actually use them as level marks for our plans. So to do this we're going to be using the rotate tool, but we're going to be using the rotate 3D instead of the rotate 2D tool this time. So I'm going to select my levels and make sure that layer is unlocked because it's in the guide layer. There. Now you could just do this with the gumball, just sort of holding down and holding shift and rotating it there, so now it's in the vertical plane. I'll just open this larger so you can see. But I'm actually kind of want to introduce the rotate 3D tool for this. So if you hover over the rotate tool you'll see there's 2 options, 2D or 3D if you right click. So if I right click on that tool, select the objects I want to rotate. To rotate 3D you first have to kind of start the rotation axis, which means you've got to pick which axis this object's going to be rotating in, because we're obviously rotating in 3 dimensions, so it could be kind of X, Y or Z axis we're rotating in. So for this, we want the axis to actually be in this line, because then as we start to kind of rotate it, you'll see that it then gives us the correct axis for us to spin this up and vertically in the plane. This is quite weird to get used to, so I'd have a go with sort of rotating different objects in 3 dimensions and picking that axis and then rotating the objects up. Once you've selected that, you can just then pivot them up, and if you just hold down the shift key, you can lock that in at 90 degrees. Now my level 0 is also snapped to the bottom of these plans. Now what I want to do next is start to move my plans upwards to their relevant levels. So for this particular drawing, this plan here is going to be on level 0, and what I'm going to do is I'm just going to check that. If I select the move tool, we can lock this in the vertical plane just by clicking on vertical yes here, and if I just select any point on my plan, you'll see that it's now locked only in for the vertical plane there. So we can just make sure that's snapped to 0, click there. Then for our next plan, we do the same, move, lock in vertical, snap it to level 1, and then same here for our last plan, and snap it to level 2. So now you can see that my plans are all aligned to their correct levels, but obviously they're offset from one another. So what we also need to do now is kind of move them horizontally so they all align in the vertical as well. Now, because I copied these from the same points, my grid lines are all matching on all of these plans. So what I can do is I could select one, select the move tool again. Now, whenever you're doing precise movements like this, always use the move tool and not just drag it using the gumball, because it's much less precise and you can end up kind of being slightly offset on your drawings, and you don't really want that. So always use the move tool so you can pick a point and move it to another point. So select the point, hold the shift key to lock it in the horizontal, and we can hit the tab key again to lock that motion, and then just snap it to the corresponding point on the plan. And I'm just using that point on the grid line. We could use any points that we know match from plan to plan. Sometimes it's good to have a reference point on each level to do this with, but for now I'm just using my grid lines, and that's one good reason to use grid lines for this kind of thing. So, like so. So now we have our 3 plans, and they're aligned to their correct levels here, and also vertically aligned to one another. Now these levels I kind of set up at a rough floor level. I've done it at 3 meters from floor to floor, so that's kind of anticipating that the thickness of each of my floors is going to be around 200 to 300 mil, giving a floor height of 2.6 meters, 2.7 roughly. So I mean, you can vary this, but it's good to sort of set up these levels at the beginning, because then it makes it a lot easier to start to snap all the modelling you're doing to the correct floor level as you go forward. So now we're going to start 3D modelling, and we're going to start with our basic floor plates. Now these are just going to be simple rectangles which we're going to extrude into boxes, and I'm going to do that by drawing them once on the first level and then copying them up to the relevant layers. Now because we've now got all our plans stacked up on top of each other, it can be quite kind of hard to just select one without snapping to the other. So one trick I sometimes use is you can select some objects and you can isolate these objects so all you see are the objects you've selected. And to do that, if you just hover over this light bulb tool up here, this is the visibility kind of panel, and go along to this one, which is isolate objects. If you left click on that, it will just isolate that selected plan. Then if I go onto my floor layer, make that the active layer, we can then start to model in floor. Now to do this I usually use the box tool, and I always use the 3-point box tool, as I find this one the easiest to work with. A lot of the kind of box tools you sort of specify the first corner and the last corner and then give it an extrusion height like so. But with the 3-point box tool, which is this one here, and sometimes I actually drag out this box so I can have it on the side because I use it quite a lot. It's a lot easier to sort of work with. So to draw a box using this tool, you specify the first point, and then the length of the box, then the width of the box, and then the extrusion height of the box. And for this, it's going to be 300, which is my floor plate depth. I'm just going to set my view to ghosted as well, so you can see the objects as I model them. So that can be my first floor plate there, and you see I've kind of snapped it to the guidelines because these pieces are going to be kind of external pieces which aren't going to be part of the floor plate there. So once you're happy with that and we want to get back our other layers, if we just select the objects and we right click on them, it unisolates it and brings back our other layers. Now while I'm working with the floor plates, I'm actually going to lock all my 2D line work layers, and because they're all in this kind of layer folder here, I can just lock the top layer, the 2D line work layer, and it will lock all the layers below that as well. So that's quite helpful using layers within layers like that, so you can then lock all of them at the same time. So that way I can't accidentally select any of my 2D line work while I'm working on my floor plates. So now we've modelled one floor plate, we're literally just going to use the copy tool, lock it vertically in place, or when we do this we could go back to our 4 views, go on our front view here, and we can just drag this up, hold down the shift key and snap it onto its relevant layers. And if you look as we do that, it's just copying them into place on our levels there. So now we have a floor plate on each floor, like so. So now that's modelled, the next part we want to look at is extruding out the external walls. So I'm going to go to my walls, double click on my external layer, so I'm drawing on that, and basically we want to be extruding these walls in red. So I'm going to unlock these 2D line work sections. Now you see here, as I've drawn them, I'm just going to isolate these layers so you can see it more clearly. Now each of these walls I've made sure are completely joined as a solid polyline, which we did discuss in the last session. And the reason for this is when we do this stage and start to extrude out these walls, if they're not closed polylines like this, then, and you can kind of check that if you go to the properties, if it's a closed curve it will come up as closed curve there. So if it's not, when you start to extrude it, it won't become a solid poly surface or shape, as I call it. So, and that makes it really tricky moving forward to use some of the tools we'll be going over. So it's really important to make sure these are closed curves before you start this next step. So I just unisolate that. Actually, let's unisolate that for now. And we're just going to isolate these 2 layers and their corresponding floor levels. So what we want to do is we want to extrude our wall plates up so they meet the bottom of this floor here. So I'm just going to start with this wall, and the tool for this is Extrude Crv, because we're extruding a closed curve there. So Extrude Crv, this one here. Now as you can see, once I've selected that, it then allows us to drag up this curve up to the next level, the point. Now one thing to note is when you first use this, this option here will be ticked as no, and what that means is when you extrude it, you'll have a kind of open box, as you can kind of see here, that it's not filling in the top or the bottom, and that presents a problem for us later on when we want to start using what are called Boolean tools to help subtract and add 3D objects to one another. We just always want to make sure that that's solid, just to tick that as yes when you do it. If for some reason you've left it as no and you've done a lot of extrusion, don't worry, because you can add it later. So if you've done it like I have now, and now you see it's still got that hole, top and bottom, we can do what we call capping solid objects. So if I select the object and type in cap, that then adds a top and a bottom, making it a solid object. Now we can actually do that to all of our curves at the same time. So what I'm going to do is I'm going to lock all the layers apart from my section thick, which are my exterior walls on my 2D line work. Then I can just drag over, deselect the floor there, and I can deselect the one I've already done. And then with these selected, we can just do the same function, Extrude Crv, make sure it's solid, and snap it onto the wall. And there you can see we've already got then all our solid walls extruded. Now I'm just going to go ahead and do that for the other two layers. So I'm going to pause the video, extrude those walls, and then we're going to carry on. So now you can see that I've extruded out these external walls, and we're starting to get something that resembles our 3D model, with simple walls extruded and our floor plates in place. Now obviously when you extrude, for these back windows here, we actually want windows in place, and at the moment we've just got these strip walls. Our windows on this plan aren't full height like this, they actually have a window sill which kind of goes up to about this level here. So we're going to need to model that in and add it onto our extruded walls here. So what I'm going to do is I'm actually just going to hide my 2D line work for now to make my model a bit cleaner, and I'm just going to simply start to model in my window sills just using the box tool. And we're just going to do that just simply using the 3-point box tool like this, and I'm going to give them a height of 1 meter. Now I'm actually going to do it on this first level first. So, and because I made all these windows the same width, I can just copy this into place. Like so. Now at the moment, because I've drawn those as separate boxes, they aren't attached to this 3D model at all. They're all kind of independent models. And what I quite like to do going forward is keep my models unified, so they're sort of one whole model. This is just kind of preference. I quite like to model this way because it makes me kind of make sure that everything's a solid each time I'm modeling. What I'm also going to do actually in this case is model up the top of the window too, because I don't want the window going all the way up to that floor plate there. So we're just going to do the same, and I'm just going to model it down here and then move it into place. I use the box tool quite a lot for this kind of modeling because you can start off quite simply just modeling it as a box, and then you can refine it a bit later. So we're just going to copy that up there, and then we're just going to move it into place. Like so. I made one extra there. We'll delete this one. So now those are modelled, I now want to kind of unify these elements together, and to do this we're going to start using these, which are the Boolean tools in Rhino, and these are really useful for whenever you're doing any 3D modelling here. This Boolean Union and Boolean Difference tool are probably going to be your most used tools when you start 3D modelling within Rhino, and I'll kind of use these all the time when I'm doing any of my modelling, and these are the most useful tools to know. So the first one we're going to go through is Boolean Union, and what that does is it unifies 3D shapes together. So let's say I want my kind of top of my window here, this part, the edge, and this side wall. I want to unify them all as one model. So if I select them, then select Boolean Union, what that does is that now has unified those so they are all one continuous model. And I'm actually going to do that for all these walls here. So all my external walls on this level are unified, like so. And the reason I do this is I just like to keep my models quite neat and tidy, and there's no reason really to have these kind of floating as independent elements, because I can trim them down using other tools later on. So I just quite like to keep everything sort of unified and together as I model and go forward. So that's the Boolean Union tool. Now we're also going to look at the Boolean Difference tool, which is the opposite of this. It allows us to cut holes or cut objects out of one another. So it's basically subtracting one 3D shape from another shape. And to put this into practice, we're going to do this by cutting out the holes in the floor for where the stairs are going to come up. So I'm just going to hide the walls for now so we can see. And if we just go onto the floor layer when we do that, and then we're going to bring back our line work. Now you can see here the stairs are kind of in the same place on each level. So what I'm going to do is I'm just going to use the box tool, and we're going to be drawing out the box that will be kind of the void that the stairs sit in. So I'm just going to draw that out, and I'm going to cut it through. We're not going to cut it through this bottom step because this is our ground floor and we actually don't have a staircase going through this floor. So just these two. And sometimes when I'm doing Boolean difference, I like to make sure, because I'm going to be subtracting this object from these two floor plates, I want to make sure that it's cleanly gone through. So sometimes I use the gumball tool just to move it so the object is clearly going through both of the objects, like a cookie cutter almost. It's like chopping it down the middle. So once that's done, we select Boolean difference. We select the polysurfaces, which are the kind of shapes here that we're subtracting from. So I'm subtracting from the floor plates. So I select these first, hit enter, and then we select the object that we're minusing with, which is this. Then hit enter, and there you can see, if I hide these, that it's chopped out those holes in the floor plates. So if I bring the walls back, we've now got our external walls and we've got holes in the floor for where the staircase is going. Now I'll use those tools all the time. They're kind of the most useful 3D modeling tools, and it's really important just to kind of get a hang of using those. You could use the Boolean difference tool for kind of cutting extra doorways in walls. I might use it for kind of if I was wanting to cut a door through this wall here, we could use it. So we could, like so, and it allows you really quickly and easily to start chopping up and refining your 3D models. So I definitely get used to using those two tools, and they're probably the most useful tools you'll find in 3D modeling. Now we're going to stop this session here because that was all we needed to cover for this first stage. We've basically looked at simple setting up your 3D model space with your layers, rotating and moving your plans into place so you can start to extrude from them, and then we've looked at extruding walls up and subtracting and adding shapes to one another using the Boolean difference tools. So I'm going to now extrude up both the internal walls on my plan as well, so they match with this, and start to put in all my window sills using the Boolean Union tool and Boolean Difference tool to cut any extra holes I need. And we're going to be looking in the next session at adding more detail into these plans and looking at the next step of using blocks within 3D. Much like we covered blocks in the 2D session, we're going to be looking at how you can then start to use those in 3D modeling as well. So that's it for this session, and I'll see you in the next video.